Welcome to Acid and Base Safety Training. As we all know, the Global Harmonization System, GHS, is an international approach to hazard communication and a way to standardized container labels and safety data sheets. You've done GHS training as part of our safety program, however, it's pretty general. WaterTech provides job-specific training as it relates to hazardous chemicals and how to work safely around them. By law, we are only obligated to provide these trainings once every 3 years. But based on its importance and our commitment to safety, it is good to go through it once a year because it's something that we're around all the time. And the more we know, the safer we can be for ourselves, our drivers, and our customers. So we'll start with acids and bases. Today we're going to do a little regulatory review. We will talk about corrosives and their physical characteristics, what to be aware of from a health perspective, and some basic first aid measures. What are some of the physical hazards? And then lastly, what to do if there is a leak. We want to make sure everybody understands how to work around acids and bases safely. These are substances that you could be exposed to on a regular basis. And as a result of that, we need to make sure you understand what they are, and how to work with them safely. OSHA and DOT define a corrosive as anything that causes visible destruction to your tissue. Each of these organizations focuses on safety as it relates to different areas. The DOT applies while the products are in transit, or if our drivers get pulled over. OSHA applies when it gets in the plant. And the EPA is focused on environmental issues. The EPA defines a corrosive as exhibiting a pH of less than or equal to 2 or greater than 12.5. But realistically, the biggest thing for you is to know that if you get caustics or corrosives on you, it's going to cause a problem with your skin and your tissue. We will not cover corrosive gases because we don't really deal with corrosive gases. In the past we used to run into gaseous chlorine, but other than that, we're really not dealing with any corrosive gases. You may still find a few chlorine dioxide generators out there that use chlorine gas. So just be aware. We see chlorine and sulfur dioxide a lot. We see anhydrous ammonia in any ammonia refrigeration system. Anything that's making something cold or frozen, you're going to have ammonia refrigeration and you'll have anhydrous ammonia on site. But again, this is not something that we deal with. Moving on to physical characteristics. We do not deal with many if any corrosive solids. If we run into some corrosive solids out there, they will be in the form of flakes, pellets or dust. To know for sure, refer to the label or SDS. The most common examples of corrosive solids we might see are sodium hydroxide and sodium carbonate. Sodium carbonate, or soda ash, is not typically corrosive. It is used to clean up a lot of common chemical spills. As a result, you may see it in a customer's facility. Liquids are the most common corrosives we run into. And we're not just talking when we are selling caustic soda. Most of our internal boiler treatments and our scaling corrosion inhibitors for cooling systems are all finished with caustic soda. This is because these formulas, which are a blend of ingredients, like to stay in solution at a low pH or a high pH. If the pH is neutral, you're going to have a 7-layer salad where the ingredients don't stay in solution. Typically, when you look at a lot of our formulations, the pH will be on the high side, or alkaline side. And that's why we're going to have that corrosive diamond or symbol on the label. Liquids assume the shape of the container. And under containment, it's going to travel to the lowest area. One of the main hazards we deal with is pumping chemicals. We had an incident where we were transferring chemical, and when the pump came on there was a little pinhole in the plastic tubing, and chlorine came out and squirted our rep in the eye. We got him to the safety shower right away. And eventually, he went to the hospital as a precautionary measure. Everything was okay. But again, we run into these situations where you don't think something will happen, and you're not wearing your safety glasses, and then something goes wrong. Make sure to always wear the proper PPE. And when you're working on pumps, de-energize them so that you don't have to worry about this type of situation. Corrosive liquids, again, acids, caustics, a lot of our products are considered corrosive liquids just based on the finished pH of them. pH is the measure of the acidity or alkalinity of a solution. It's used to indicate acidic or corrosive. We kind of know the 0 to 14. Most of our internal and scaling corrosion inhibitors will probably have a pH around that 11 range. Some of our sulfites may be more on the acidic side. A pH of 7 is neutral. Solutions with a pH below 7 are acidic, and as you go above 7, it's going to be more alkaline or caustic. To tell the pH of a product, please rely on the safety data sheet or use litmus paper. If you do have spills, it's one way to know if your spill is okay to discharge. You can use litmus pH paper and just make sure that it's neutralized and that you can keep it down the drain. Here are the pHs of some common solutions. Due to its low pH, Coke was used as an anti-seizing agent before newer technologies were developed. We will now cover the health hazards of acids. This is what we are most concerned about. We need to understand the labeling on containers, the physical characteristics, and what happens if you get something on you. Acids can be harmful to your skin. Typically, if you get some acid on your skin, you're going to know about it pretty fast. Caustic, on the other hand, is a totally different burn. Read labels and SDSs before handling any chemical. All of you have personal protective equipment to wear. If you are getting product on you, it's probably more negligent on your part, not wearing the right stuff at the right time. If for any reason you feel you need additional safety equipment, anything, just bring it to our attention. In addition to physical contact with acids, you also need to worry about fumes. One of the acids we commonly run into is hydrochloric acid. If you're using it, make sure it is in a well-ventilated room. Extreme corrosion will occur in areas that are not ventilated. It is important to avoid long-term exposure to acid fumes because you can develop complications. Should you get any acid on your skin, the severity of the reaction will depend on the concentration of the acid and the type of acid. Immediately, get to an eye wash or some kind of safety shower. OSHA regulations require our customers who use corrosive chemicals to have a tempered safety shower nearby. The safety shower needs to be located in an area you could find in 10 seconds if you were blindfolded. If you get acid on you, you're most likely going to feel it right away. Get over to that safety shower. Flush with copious amounts of water for 15 minutes. And don't be afraid to seek medical attention. Safety is our #1 goal. You only get one set of eyes. If you have any concerns, go seek medical attention. Due to the sensitive nature of our eyes, minimize your eye exposure. Wear glasses and a face shield. Safety to your eyes can never be overemphasized. If you get chemical in your eyes, flush with water for 15 minutes. Then seek medical attention. So that's acids. Again, if you get an acid on you, you're going to know quickly. Wear all the proper PPE. If you do get it on you, get to a safety shower and rinse for 15 minutes. Seek medical attention immediately if needed. So that's one class of corrosive. The other class is at the other end of the spectrum, when the pH is above 7, that basic, more alkaline type of chemistry. The reaction from contact with caustics might feel like some heat or a little itch. If left unchecked, caustic can cause deep, scarring wounds due to its emulsifying nature. One customer needed skin grafts on his foot after coming in contact with his foot and not realizing it until hours later. Any exposure to your eyes with caustic soda should result in immediate flushing of water for 15 minutes. Even a drop of caustic in your eye can result in permanent eye damage. Always wear eye protection. Caustics also have a very slippery nature to them. As you can see from this picture, contact with your eyes to corrosive liquids can result in serious, irreparable injury. Now we will get into acid and caustic physical hazards. Acids are going to react with certain metals and form hydrogen gas. Not all metals are compatible with acids and some need to be lined to protect them from corrosion. Stainless steel is incompatible with sulfuric acid. Don't mix chlorine and acid. When this occurs, chlorine gas or mustard gas is generated. A former WaterTech representative told the story of a driver from his former company accidentally mixing bleach and acid in a tank located in the basement of an office building. The HVAC system distributed the contaminated air throughout the building, which then had to be evacuated. This emphasizes the importance of tanks being properly labeled and drivers checking and rechecking before a mistake is made. Bases can be inorganic or organic in nature. Sodium hydroxide and potassium hydroxide are the most common ones that we're going to run into. If you get them in contact with certain metals, they can release hydrogen gas. Metals like lead, zinc, or aluminum can have this occur. If you add acids and bases together, you get salt and water and some heat. So just know that that's a heat reaction, and if you do mix them, you're going to get a bunch of solids that settle to the bottom, but again, hopefully that's nothing that ever happens. We neutralize acid spills using soda ash, which is a weak base, that won't have a violent reaction. You can neutralize strong acids with weak bases and strong bases with weak acids. Never neutralize strong acids with strong bases and vice versa, or a violent reaction will occur. When mixing acids and bases in water, remember to always add the acid to the water. Don't ever do the opposite. If you add water to acid, it's going to splash and splatter. Always add RO alkaline and acidic cleaners to water, not the other way around.